Hi guys. Alright, so this is 5.1, page 183 in your textbooks. We're going to be looking at some pretty basic things here really quick. The model that they give you to do absolute functions is they have asked you to take a look at x f sub x, I want to take that back a little bit. F sub x, which we know as y, equals the absolute value of x, and then what coordinate that's going to give us. Remember, and this may be difficult for you to grab onto and get used to, the fact that we're talking about f sub x is the same thing as y. So that's our coordinate now. Now, what they're telling us to do is we're going to use values of x, -2, -1, 0, and +1, +2. This is a common model in graphing, so it shouldn't be much trouble for us. If we take f sub x and say it's equal to the absolute value of x, what's the absolute value of -2? Well, we happen to know that's going to be +2. Every absolute value is positive. All right, so secondly, -1 is 1, and 0 is, of course, 0. 0 is not positive or negative. And 1 and 2. So if you see this, and you do your chart and say, oh, okay, I can figure out what my coordinates are. My coordinate is -2, 2, -1, 1, 0, 0, which is the origin, and 1, 1, and 2, 2. Not really much challenge to that. Now, having said that, and knowing that there's not a lot of challenge to that, I'm going to graph that. And if I'm going to graph that, I'm going to graph the positive ones from the origin first, just because I want to. So here's the origin, right? Check, got it, right? Next positive one is 1, 1. No problem there, I got that one. And then I have 2, 2. Now, knowing that this is a line that goes on forever, it goes on forever from the origin. And on and on and on it goes, and there it is. We're not done with this yet though, right? That takes care of these 3 coordinates. I need these coordinates in here, and that's where we see the infamous absolute value function. The absolute value function is going to look like this. And let's use a different color just to be sure that we understand that 2 things are going on. We have -1, 1, and we have -2, 2. So therefore, we now have the absolute value V. Now, as we go on in the example on 5.1, what they're going to ask us to do is they're going to ask us to do different things with it. One of the things they're going to ask us to do is in example 4, which is determining the rate of change. So our graph for the rate of change here, let's say I wanted to go from, I want to go from 2, and I want to say it's less than or equal to our drawing. This is a time drawing that you'll see it in example 4 and understand exactly what I'm doing. And now I want to go to 2.5. Alright? Now, of course, the thing here to recognize is I have to find both of those terms. I have to find 2. Well, here's 2. Right? And 2.5 is roughly right about here, right? Let's change this a little bit. Let's change this just a little bit. I'm going to go back to here, and I'm going to erase this because I want to have a bigger picture, so we can look at it a little bit more clearly. Let's say I'm going to go to 5. All right. The problem that we have when we look at that is that yes, that gives me the rate of change from here to there. Let me keep my colors the same. Alright? This is what we're looking for. That's this line right here, right? Now, but, take a look at this. So, anytime I say then what I know to be true is that that's going to be filled in. If I say this or this, that's going to be a whole. Because it can't be equal to that. So it's got to be a whole. Now, having said that, what if I said I wanted to do this same operation with negative x is equal to f sub x. Well, then my figure is going to look like that, because I've got the negative outside of there. If it's on the inside of there, it's the same thing as negative x, as x. Okay? Alright, so that's our 5.1. I'm going to move on to another video so that I can do 5.2 for you. Alright. Questions are always welcome. You know where to ask them.